Jai Hind, my name is Mukulit Goel and today I am going to present a lecture on multithreading in Java, which is from the subject Object-Oriented Programming for MC first year student having subject code KCA 202. Now let me first start with the content of my slides. So the content consists of concurrency in Java, what is multithreading, what is a thread, life cycle of a multithread and programs on multithreading. So let me first start with the concurrency in Java. What is concurrency? Basically, concurrency refers to the ability of a program to execute multiple tasks simultaneously. But using Java, how will we execute multiple tasks simultaneously and utilize the maximum resources? So, the concurrency can be done using multithreading, using the classes, concept and interfaces for multithreading such as thread, runnable, callable, executor service, and the package for concurrency in Java. We use java.util.concurrent. Util means utility classes, and it is the part of the standard Java library. Concurrency enables the efficient utilization of resources, and this we can achieve by improving the overall performance and responsiveness of the application. Next, what is multithreading? Basically, multithreading is the programming language which means that we can use multithread programs using Java, and it refers to a technique in which a multiple threads execution exists within a simple application. So, in a single application, there are multiple threads and all those multiple threads helps in the execution of that application, and they can also help to achieve concurrency by means we can achieve through multiprocessing, asynchronous programming and event driven programming. So, what is multiprocessing? Multiprocessing means that we can execute more than one process at a time, like we see in our operating system. In multithreading, we can use the operating system, and it very much dependent of the operating system which is particularly in that system. So, multiprocessing is when we use more than one process or we are executing more than one process, then it is known as multiprocessing. What is asynchronous programming? Asynchronous programming means when a single program or a multiple program are independent to each other but helps in execution of the application. Event driven programming is when we use like key events, mouse events, when any execution have been done with the use of keyboard, mouse or any other peripheral device which is used for the execution of that application. What is a thread? Basically, thread is a single thread, is a sequential program when executed has only single flow of control, and at any instant there at most only one instruction that is being executed in the program. So, it is a thread, but there is something which is known as multi-thread. So, multi-thread program is one that we can have multiple flows of programming when executed. So, we can achieve concurrency by the use of even a single thread program, or we can also achieve it using multi-thread program. Like for example, I have shown in this slide that we are working on a web browser. So, at the same time, we are scrolling the page, we are playing the sound, we are printing a page, we are downloading an image or we are downloading any video. So, we are doing that we are in a single web browser, we are doing these multiple tasks at a single time, or we can say at a same time. So, the thread, basically what is a thread and what their relation with process? Basically, thread is the combination, process is the combination of many threads. So, one process is the combination of many threads, and those many threads have help in the execution of that process and or may help in the completion of that working of that application. So, processes are typically independent. Each process is independent, like Microsoft. If we talk about Microsoft Office, so Microsoft Word is a different process and Microsoft PowerPoint is a different process. Maybe it also because of they are in a single package which is Microsoft Office, but still these two processes have their own, they have their independency, and both these applications are not dependent on each other. But the threads in the PowerPoint or the threads for the execution of Microsoft Word are dependent to each other, or we can say that these are the subsets of a process. Processes carry considerable state information. What does considerable state means? Basically, process have 5 states. First is ready, first is new, second is ready, third is running, fourth is waiting, and fifth is terminate or exit. Or exit. Okay, so these are the 5 process states. So each process carry this state information, where is our basically our processes going on. So when we start a process, then it will be new, then it will go into a process control block, so that will be in the ready state. When we start executing on it, then it is running. If we have any high priority process, then it will go in waiting, and from waiting, when it comes, it will again go to the ready, then again from the running, and at the end it will terminate or exit. So process carry considerable stored information, whereas the threads within a process share state as well as memory and other processes. Like we are printing some page. So when we print some page, the multi-thread share the process by which we are printing the page, and also have the information about the memory which we will be used for the execution of the printing of that page. Next, process have separate address space while threads share their address space. Process interact only through inter-process communication mechanism, while threads execute through, threads also help in this inter-process communication. And the next is context switching between the thread is the same process that is typically faster than context switching between processes. Means ki in threading we use context switching. Now, what is single threaded versus multi-threaded program? So in single threaded program, we can see there is only a single thread which is executing under a program, and in this we have multiple thread. Maybe say it is a thread, so there is a thread in B thread. So for the execution of this program, we need the synchronization between both the states and both of these threads. So we use both the threads for the execution in multi-threaded program, and when there is a single thread, the program or the process execute with the help of this single thread only. Thread ecology in a Java program means how the thread is executed. We start with the main thread, like we can say A and B. So first we start with the thread A, then we start with the thread B, and if requires, then if we need thread C, then it will go to the lifetime of the thread C thread. Otherwise, it will go to the main program where we execute both these threads, and we define the function, define the method on which these two threads will work. Next, how we will launch a Java thread. So for Java thread launching, we need a package which is java lang.thread, and we use two ways to define a thread. First is extend the thread class, and second the implement the runnable interface. And for this we need a package java.lang, and the interface we call it public interface runnable. So, and for executing for extending the thread class, we need the subclass which is a thread class, and override the default thread method which is the entry point of the thread, like the main string method, which we see in the previous diagram, like we have, like in this program. So these are two threads which are executing, but for the execution we need started by Java from main string. So all these two threads will execute by the method which is defined in main string. How we create a thread? In Java, threads can be created by extending the thread class or by implementing the runnable interface. It is the most preferred to implement runnable interface so that we can implement the properties from the other classes. How we implement the properties from other classes? We can implement the properties by the classes using overriding. And we implement the run method, which is the starting point of the thread execution. How we running the thread? This is a simple small program which we shown as an example. First, I will create a class myThread that implements runnable method, and in runnable method what we will do, we started the run method, and that run method we say that thread is started. In the main class, what we will do, we create an object with the thread and start the running of this thread. So what we write t dot start, and what is t? T is the object of this thread which we have created. So calling the dot run does not start the thread, it is a simple method call, but for running of the thread what we need t dot start. So by using the t dot start method, we start the running of the thread. But this t dot start, what we will do, it will do whatever we have, method we have written in run method, function we have written in run method, that will be executed by defining t dot start. So what is the output of this program? The output of this program is thread started. What are the methods of the thread class? The methods of thread class are start, stop, yield, is alive, sleep, suspend, resume, current thread, and join. All this I will explain one by one. What is the start method? Start method is the method that makes the request to an operating system for the creation of the thread and responsible for the transitioning of the thread from born state to a ready state. Stop method, it kills the thread, or we may say that stop method will stop the working of the process and send the thread into a dead state. So if we executed the stop method, then that thread will be executed from the starting point, from the start method. If we call the stop method means we have killed that thread and that thread will not be started again. Yield method, it is a static method that causes currently executing thread to yield the control. If there are any other runnable threads whose priority is at least high as this thread, then they will be scheduled next. And the yield method working is dependent on the OS. On the OS, the features of the OS or the working of this OS will help in yield method. Is alive, and this thread has started, so we can use is alive for that thread, and in this state the run method executes normally. What is sleep? When we send some thread for the hold for some time, so we use sleep method like we do in our normal life. When we want to take rest, we normally sleeps. So the thread remains in the sleeping state until the sleep time interval is over, and this interval might be in seconds or in terms of milliseconds. Next, suspend and resume. Suspend means send the thread into suspended state. After suspend state, the thread starts from ready state, and resume bring the thread into the ready state from the suspended state. So all these two states or these two methods we use simultaneously. First we suspend and then we resume. Next is join. Join method is used to wait for the thread to terminate. and it will be executed only after the death of the thread. This is the difference between multitasking and multithreading. What is multitasking? Multitasking allows the CPUs to perform multiple tasks, while multithreading allows the CPU to generate multiple threads from the task and process them simultaneously. In multitasking, we involve CPU switching. In multithreading, we will involve CPU switching between the threads. So, in multithreading, we can increase the computational power. In multitasking, the processes will be stored in share the different memory, while in the multithreading shares the same memory or allocated the same memory. Multitasking involves multiprocessing, while multithreading does not involve any multiprocessing. In multitasking, the speed is slow. In multithreading, speed is fast. In multitasking, the termination takes comparatively more time than the termination in the multithreading. The isolation and memory protection in multitasking is yes available, while in multithreading there is no memory protection or isolation. Multitasking help in developing efficient program, while multithreading help in developing or working of efficient operating system. Next, what is a thread life cycle? So, as I have told that the process have 5 states. In the same way, thread is also having the 5 states. First, new, then start or ready, then runnable, running, and terminate. But the thread life cycle is divided into 2 phases. First is the programmer, and another state is scheduler. Means when the programmer starts the thread, then with the help of scheduler, it will be going to the simultaneous states, whether it is runnable, whether it is running, whether it is in a waiting or block state, or maybe the thread is in a dead state. So these 4 states are controlled by the scheduler, while the new or starting a thread will be dependent on the programmer. Next, what is the new state? The thread is considered is not alive, while in runnable means ready to run. So in this state, the thread starts its life and is waiting for its turn in the processor. In running state, the thread is executing. In dead state, its run method completes, and in block state is waiting for the resources that is held by the another thread. Hold or blocked or waiting is the same state. So that is the life cycle of a single thread. Now we talk about the life cycle of a or I may say the life circle of the multiple thread. So in multiple thread, what we have started, now we are ready to run. By scheduling, we are running, or we have completed our task. But after running, when we are entering into a non-runnable state, means when we are entering into the block or waiting state, in what all states we have to go? We have to go into the sleeping state, blocked for join completion, or for the block for input output operations. And there are 2 ways: waiting for the notification or blocked for the lock execution. So when we leave non-runnable state, then we again go to ready to run. Then again it will come into the scheduler, then again it will run, and again it will complete dead after completing its execution. That there are 2 ways of thread creation. One is java.lang.thread, which I have told earlier, and implementing it using a java.lang.runnable interface. If you extend the thread class, that means subclass does not extend any other class, and it will implement using runnable interface. Now it is the states, how any thread will go into any state. New, for new we use final thread.state new. For runnable we use state runnable. For blocked we use state blocked. For waiting we use waiting. For timed waiting we use timed waiting, and for terminate we use terminate. It is just a declaration of all these states which we are using. Now comes the Java program on multi-threaded execution. What we have done in this program. So in this program we have created one class which is threadx, and what it implements runnable state. Now by using void run we give a method for the thread which is I, created a thread I, and we have given some time for the thread, means how many times the thread will execute. So by using a for loop, what we have given, that thread will execute only to a 5 times. So thread I 5 times, thread j 5 times, and thread k 5 times. Now this is the run method. Now what we have created a main class in which we have done starting of this thread. So before starting T1, T2, T3. So what we have do for thread XYZ, we created a thread object of the thread with the name XYZ, and we assign these thread values, object values, to a thread state T1, T2 and T3. So what we will see that the first thread is thread X, next thread is thread Y, and third thread is thread Z. So we created the object of all these threads with the name T1, T2, T3, and what we have do, we started the threads T1 dot start, T2 dot start and T3 dot start, and when all these threads will be executed, it will display a message that multi-threading is over. We have executed this program. Thread Y with J1 means first thread Y is executed 2 times, thread J executed 1 time, then thread Y will execute 3rd time, thread Z is executed 2nd time, and thread Y executed 4th time. So with this we can see that thread is executing. Now thread X, we will call it above. So then thread X will execute 2 times, then again thread Z executed 3rd, and thread Y executed 5th time. So after that thread Y is executed 5th time, we can see that it's saying that existing thread Y, and when now that after executing of thread I 3rd time, now the thread Z executed 4th and 5th time, and thread X is executed 4th and 5th time, and after the execution of all these threads all 5 times, it displays a message existing thread X, existing thread Z. So in this way, in multi-threaded environment, the threads are executed using the run method and started using the T1 dot start method. With this, I am going to